Is the Vice President for INSITU for Government Affairs, but important, he is a rated commercial pilot. He's a certified instructor for a pilot. He has thousands of hours. He is a member of the Board of Directors for the Association of Unmanned Vehicle Systems International, we've worked together on a number of items. Paul is a contributor to the small UAS rule making that the FAA has been working on for the past 5 years, and also contributes internationally for ICOA. Paul is a graduate and a longtime contributor to Embry-Riddle, and left Embry-Riddle probably, 2007, 2008 to join INSITU. And a small piece for those of you that don't know INSITU, INSITU was a company that started commercial drones for fishing applications up in the Northwest. Great success. 9/11 happened, the government became interested in some of the INSITU capability, became a wholly owned subsidiary of Boeing. These may be things you're going to talk about, Paul, but now is focused on commercial applications in very many interesting ways. So here's a company that's been successful, highly successful, and Paul, we're delighted to have you here, so thank you very much.
Hey, well, good morning, everyone. Really a pleasure and an honor to be here. You know, as Grant said, I did come from the world of academia. I spent 30 wonderful years at Embry-Riddle Aeronautical University. And I was recruited by the former president of that institution to join a little company back in 2006 called INSITU, which was in the process of developing a small robotic aircraft, primarily to support the tuna fish industry. To go out and fly off of a tuna boat and spot fish, things like that. That morphed into a lot of other things, which we'll talk about. But I was recruited by the former president of Embry-Riddle to join that company to try to figure out a way to advance the technology into the commercial arena. Was there real applications for this, to get it into the airspace, to use these things, not so much to support the warfighter and the defense industry, but to look at what the opportunities were for commercial and civil. I was pretty comfortable at Embry-Riddle. I was there, as I said, for 30 years, tenured full professor, the whole 9 yards. But I said, yeah, it was time for a change. And how tough could this be? I mean, these are little toy airplanes. You go out there and fly around. It's got to be a piece of cake. We can knock this thing out in a weekend. Guess again. It's really become quite a challenge, and has made my hair turn even grayer a lot sooner than I had hoped. I don't know if you've ever seen this game at an arcade or whatever. I use this analogy quite a bit when I speak about what's been going on over the last 7 or 8 years. It is really a whack-a-mole game. Just when you think you've conquered the major issues to move this technology forward into the national airspace, another one pops up. And it's the never-ending conundrum. I mean, it just keeps on keeping on. Every day is a new challenge, and I'll show you some of the new things going forward. You know, as Grant said, I've been a member of and kind of joined at the hip with the FAA for the last 7+ years. I was a member of the small UAS ARC that actually put the initial set of recommendations in for the small NPRM that came out last Sunday. 5 years, 10 months, 15 days from the date that we put the recommendations in. We're finally looking at an NPRM. So that kind of puts in perspective exactly, you know, what we're up against here in terms of moving the needle. That's the downside. The upside is, I would say with relative confidence, that the past year has probably shown more needle movement than in any previous year. The fact that there isn't an NPRM now out on the street, plus a lot of the opportunities that were addressed during the development of that NPRM in the concept and construct of FMRA 2012, which was mentioned earlier. A lot of things have transpired in trying to address the things that Congress mandated to the FAA. A lot of those things we had input to and have taken advantage of. And I wanted to just kind of go through some of the successes and then look at some of the additional challenges that we face to really go to the next level. But the whack-a-mole game is never going to end, as far as I can tell. This is, these are the moles, that we're constantly whacking at. Most of them should be fairly familiar to all of you. You heard that, back in 2005, actually, FAA designated UAS as aircraft. That changed the game remarkably and substantially. Industries that were basically out there doing their thing, the RCAPA group, the Remote Control Model Air or Photography Association, was out doing roof surveys and things like that using very small systems. Those industries were shut down basically overnight when the proclamation became apparent that these things were going to be aircraft and therefore were going to be regulated. Life changed. We're kind of limited to operations within segregated airspace. That's going to be part of our life for the time being. And it's the kind of thing that we're looking at taking maximum advantage of as we look at opportunities for the commercial civil side of life. The reg delays, international harmonization, a lot of work being done in that regard. As you know, ICAO is finally standing up a thing called a SARP, a Standards and Recommended Practices panel, that'll actually begin putting together the regulations for operations of UAS across international boundaries. EASA, JARIS, all of the European agencies are all getting engaged in that effort, and we're supporting that considerably. Blurred lines between recreational and commercial, we know those exist. We're trying to work with those as well. Lack of design and construction standards. As a commercial company, it's really tough for us to complete the process of developing a technology roadmap. Where do we want to go with our company? What kinds of things do we want to develop to solve the problems? Well, without having a good design and construction standard in place, it's pretty tough to do that. So we're working those issues as we go forward. Pilot training we've talked about. We've got an air traffic system that is primarily never been designed to accommodate unmanned systems. It's a manned aircraft world, and we're talking about an airplane without a pilot in it. So we're in a situation now where we have to modify or adapt the current air traffic control system so that we can operate these systems safely in the NAS. The technology challenges are apparent. We heard them mentioned earlier. The detect and avoid or sense and avoid and command and control technology issues are huge. Those are opportunities for the smart people in this room. I'm a 43-year resident of Florida. A lot of brilliant people in this state. A lot of them are in this room. There's tremendous opportunity out there to provide input to solutions to those two big technical challenges. And as a manufacturer, I implore you to get involved, get engaged in that process. A lot of things have been done. A lot of things are ongoing to move that needle even further, but there's a lot more work to be done going forward. This is an FAA slide. This is right out of their roadmap. These are basically the three steps to getting this problem solved. Three phases: the accommodation, the integration, and the evolution phase of moving this needle to the far right, where UAS are routinely provided access to airspace. We are probably at the mid to late end of the accommodation phase. All the things that have been going on over the past several years, COAs, experimental certificates, restricted category certifications, the test sites, all of these are essentially accommodations, basically adapting existing regulations to allow, to a maximum extent possible, UAS operations in the NAS. We got to move beyond that. Time to move into the integration phase, and there are things being done, things that were originally outlined in the FMRA that does move in that direction, and we're going to talk about those a little bit here in a second. Evolution, that's where the target is. That's where we want to be in next gen, in 2020 and beyond, where UAS are part of the national airspace structure. They are no longer just accommodated, but they are granted routine access, file and fly access to the airspace. That's the goal. I may not see it in my lifetime, but we're certainly going to give it a shot and get as close as we possibly can, while we have the strength. One of the things that came up in a lot of the ARC deliberations several years ago, and in the development of the roadmap, was an attempt to figure out a way to operate unmanned systems in the national airspace, again, within the confines or bounds of the existing rules, but use that opportunity to provide FAA with real operational data, information that they can logically and completely use in the development of rules going forward. We had deemed in the whole ARC process, in the development and input to the roadmap that we provided, the concept of developing Pathfinder programs. Pathfinder is essentially just that. These were kind of out of the box, risk-based assessed operations going forward, where we could operate unmanned systems in a variety of different ways, hopefully beyond line of sight, really kind of stretching the envelope. Not so much to go out there and make huge dollars and be a major commercial enterprise, but really to find out what the real issues were associated with operating these systems in the national airspace. One of the things that we were advocates for in the early days was the addition of, or the inclusion of, a block of airspace about as far away from Florida as you can get without starting back again. And that's up in the far north slope area off of Alaska. Chukchi, Beaufort, and Bering Seas. If you look at FMRA 2012, you'll see specific language in there that calls for the establishment of a segregated airspace that would provide opportunities for small UAS to operate beyond visual line of sight under 2,000 feet for commercial purposes and research. That got into the FMRA. It was laughed at initially by the FAA, but they came to their senses and said, wait a minute, we might be able to actually use this to our advantage and do exactly what the intent of that input to FMRA 2012 was. Really fly systems up there, fly them beyond line of sight, open the door to commercial operations and kind of move the needle and use that to build on additional regulation development going forward. So, little old INSITU, we petitioned FAA and basically tied in with those guys and tried to figure out what the most logical path was to actually get this done, to become a pathfinder in the Arctic operation. What we ended up doing was working with the Los Angeles ACO, the Aircraft Certification Office, and decided to make an attempt to utilize what INSITU already had, and that was a system that was already accepted or had prior acceptance by the U.S. military, therefore giving it the opportunity to be approved under FAR 142125B, which is essentially a restricted category certification. I won't get into the gobbledygook of the rules, but there is a path in that regulatory structure that allows for aircraft to be certified under restricted category for aerial survey. So working with the FAA, we took the Scan Eagle aircraft, which was kind of our bread and butter at INSITU, and made application under 2125 to get a restricted category certification on the vehicle, based on prior military acceptance. Scan Eagles have been flying around now for a while. We have close to 1 million hours of log time on them. They haven't hurt anybody in that 1 million hours. Their entire life has been spent serving the military, obviously. This was really the first attempt at true commercial opportunities to deploy that system that had been previously accepted for military use into a commercial vein. And we did it. The FAA, again, was ultra cooperative in this. We began the process to get the approvals to do this in December of 2012. By June of 2013, we had restricted category certification on the vehicle, which is pretty remarkable, 6 months to make that happen. We did our first operation in the cooperation with ConocoPhillips Oil up off the north slope of Alaska in the Chukchi Sea in the summer of 2013. It was late in the summer of 2013. Unfortunately, if you know anything about the weather in Alaska, JC Coffee certainly does. When you get into August, September, the weather up there is not exactly conducive to a lot of UAS operations. So unfortunately, even after all the work in getting the vehicle certified, we only got 1.5 hours of flight in 2013. Not good enough, but it opened the door. It gave FAA confidence that you could do this, you could do it safely, you could operate beyond visual line of sight, albeit in segregated airspace, but it provided a great data path for them. So we expanded that program into 2014. 2013. What year is this? 2014, yeah. just backtrack a little bit, just to kind of calibrate everybody's thinking. This was the process that we went through. If anybody's familiar with aircraft certification, you know you have to have a certified aircraft if you're going to operate in the NAS. For commercial purposes. That's what the regulations say. This is the path to certifying an airplane. Under no circumstances did we get any waiver to any particular regulation that would be applied to a manned aircraft to get this vehicle certified. This is all of them. I mean, it really was quite the challenge, right on down to the whole issue of placards and markings for the vehicle. The requirement basically in the regulations were that you had to have an aircraft flight manual on board the airplane. You had, if it's a restricted category aircraft, you had to have placards in there that said passenger carrying prohibited. You know, we had to get exclusions from the seatbelt rules for pilots, things like that. I mean, it got down to that level of detail. But we managed to get through it all. Worked up appropriate compromises, and you know, I can say with absolute certainty that there was no regulation that was compromised in any way, shape, or form. So the picture you see there is November 202 Sierra Echo. There were 4 aircraft in that certified fleet. 202 Sierra Echo ultimately will end up in the Air and Space Museum. The Smithsonian has already put their dibs on it because it is or was the first legal commercial flight in U.S. history, done in 2013 off the North Slope of Alaska. That's our crew holding the vehicle right there. That's the copy of the type certificate sitting there on the bottom. So we're pretty proud of that. You know, it was really an enabling opportunity, something that we and others will ultimately build on, and there have been others that have joined that bandwagon. But it is an opportunity there that really needs to be considered going forward. 2014. Whole different ball game. After we proved to the FAA that this could be done and done safely, they expanded the envelope a little bit. We went from what was a completely shipborne deployment. And in 2013, we put that airplane and the crew out on a deadliest catch boat, essentially, stuck them in the middle of the Chukchi Sea. And, you know, and they flew there 1.5 hours. That was the only opportunity they had in the 30 days that they were out there. So they were out there bobbing around on this boat for 30 days and only got an hour flight in. Kind of not so good. So in 2014, we wanted to expand that a little bit. So FAA said, well, you know, the boat thing was kind of cool, but let's see what happens if you do a shore-launched opportunity. Let's get you to launch and recover from a shore-based entity, maybe out to a boat, and then recover back on land again. And that's exactly what we did. We deployed from a place called Wainwright, Alaska. FAA provided an approved corridor, operational corridor, to fly the vehicles out to the operational area in the Chukchi Sea. Flew out to the boat, basically we call it pitching it to the boat. Crew took control of it out there, flew around, recovered back in Wainwright. This last summer we got 13.5 hours of flight time in under our belt, flew out to almost 30 miles, and did so completely safely. There were simultaneous operations ongoing. NOAA had some operations going on with other UAS in the airspace. There are some air carrier operations going forth up and down the coast up there. All of those issues were coordinated, and we were consequently able to conduct the operation very safely without any issue whatsoever. Pictures from Wainwright. That's the beautiful Wainwright Alaska skyline down on the lower side. Our crew said, "Please don't ever send us back there." Yeah, it was a bit challenging, but again, very successful. It was a pathfinder. Okay, these again are opportunities to look at what the real commercial possibilities are. Albeit in very restricted and remote locations, it's the kind of thing that we will build on going forward. And you know, I think it's important for everyone in this audience to understand that you know, as Florida begins to engage in UAS activity, these are the kinds of things that are now on the table. As I said, the needle is moving. The FAA is clearly moving now to more of a risk-based approach to providing the operational approvals for UAS operations, particularly in the commercial segment. One of the things that they have learned over the past 7 years is there's not going to be a one-size-fits-all rule. Not any particular regulation that's developed going forward is not probably going to be in itself completely applicable across the board to the entire UAS spectrum. The diversity in this technology is significant. You all know that. So really the approach now is to look at each individual case, particularly from an operational standpoint, and provide the approval based on a very robust risk assessment. That's something that, you know, again, the great brains in the state of Florida can be a big part of, particularly with our university network. When you look at these operations individually or collectively, what are the risks? How do we realistically assess them? How do we build the safety cases to get the operational approvals to take these ultimately certificated vehicles and apply them to real commercial operations? The outcome from our Arctic work was exactly this. If you got yourself an Alaska sectional chart, you will now see these big red boxes on it, which were really the kind of the dream come true in the vision when we put it in FMRA 2012 to get permanent airspace established for UAS commercial operations. It is now charted up there. So kind of cool. Where do we want to go? We want to get obviously beyond line of sight. When you talk about a platform that has the capability for long duration flight, persistent stare, or long-term ISR opportunities, something well beyond what the small rule in its current state basically allows. You gotta really get out of the box. You've got to do the kinds of things we did in the Arctic, bring some of those opportunities back to the contiguous U.S., the lower 48, into much more populated and congested airspace models. Our friends at FAA are in that mode now. They are looking beyond the small rule. I'm on the current UAS ARC. A lot of discussions just last week about, okay, what are the next steps? You know, what kinds of things should we really start focusing on? And this is the kind of thing we're looking at. Longer duration, beyond visual line of sight ops. One of the things that our friends in Europe have basically come up with, and FAA seems to be slowly embracing, is the concept of EVLOS, extended visual line of sight. Kind of a new term. I hadn't heard it until last week, but it's really kind of a novel approach. It's not complete beyond line of sight operations as you might envision it. It's extended, and what that basically means is you would not necessarily be required to keep your eyes on the UAS at all times, but be able to survey all of the airspace and identify intruding aircraft and maneuver your airplane to stay away from those intruding airplanes. It's kind of the interim step between true beyond visual line of sight and visual line of sight operations. So those kinds of things are in work now. What do we got to do to build a safety case around that concept? Is that the kind of thing that we can deploy existing technology on to extend that range of operational envelope for systems like ours to do the persistent stare long duration stuff? We think there's opportunity there. Something that should be in your bag of tricks to help us as an industry come up with the right solutions to a lot of that. One of the things that has been ongoing that I'm particularly involved in, maybe some of you are too, is attempting to solve those two big technical challenges. Detect and avoid. We don't have a warm pink body in the front end of a UAS. We lose that 91-113 see and avoid rule requirement. We got to come up with some means to mitigate that particular risk. RTCA and FAA joined together several years ago, and many of you remember, certainly Rose does. They formed a special committee called Special Committee 203, and unfortunately, that committee was asked to boil the ocean. You know, they were essentially told to solve all of the evils and all of the technical issues associated with integrating UAS into the NAS. Kind of doomed to fail. Great attempt, a lot of hard work done. There were some good documents that came out of that effort, but it really didn't get us where we needed to go. So they regrouped back in 2013. RTC and FAA said, okay, cool, thank you 203. Let's try this again, but let's narrow the focus a little bit. Let's get down into the real nitty-gritty. What are the two biggest technical challenges that we have to solve? DAA and command and control reliability. And that's what Special Committee 228 is all about. Those are smart people. There's about 230 people now in SC 228 working hard to produce a set of operational performance standards for detect and avoid equipment and for command and control of unmanned systems. This, again, gets beyond what the small rule calls for, okay? This is for the longer duration, much more robust activity. Being done in 2 phases. Phase 1 of 228's effort is to come up with operational performance standards for UAS transitioning from the surface up to the basic Class A airspace. Who is the main customer for that? You might guess, the military. They have a real need to get Predators and Global Hawks and so on up into the higher echelon of the airspace. But to do that, they've got to transition through all of the lower classes of airspace where everybody flies. So we've got to come up with standards, performance standards for detect and avoid and command and control that will allow that to be safely done. Phase 2 of 228's charter is to come up with standards for operating in all the other airspace classes in sustained operations. That's going to be the long pole in the tent, you can imagine. But I got to say that there is tremendous amount of work being done, excellent work being done by the Air Force, AFRL, by NASA, to come up with solutions to a lot of these detect and avoid issues. One of the things that has really slowed things down was, well, you know, how far away should a UAS be required to be from manned aircraft? You know, if you look at the regulation, it says, you know, all aircraft must remain well clear. Don't operate so close to another aircraft as to create a collision hazard. Well, there's never been a definition for well clear. What does that mean? You know, is well clear 10 miles away? Is it 1 mile away? We don't know. So in order for 228 to do its DAA, its detect and avoid work, there had to be a definition for well clear. NASA, Department of Defense, FAA put together another SARB. This was the Safety Research Panel that locked themselves into a room for about 1.5 years and came up with a definition for well clear, and that's it, okay, right there on that slide. That's, after some refinement, kind of the target. It basically creates a volume of airspace. As long as you are not violating that volume of airspace, you are well clear. A lot of the MOPS, the Operational Performance Standards that's being developed by 228, is now being evaluated using that definition. The Air Force is conducting tests right now with manned aircraft up over Lake Erie near Niagara Falls to simply evaluate in an autonomous fashion just how well that definition works. They have a set of algorithms, it's called JOCA, it's Joint Optimal Collision Avoidance, which they are evaluating using manned aircraft, where these aircraft are actually being tested flying in 3 different flight scenarios. One is a head-to-head conflict, other is an overtake, and the other is it's kind of an orbiting intercept. And they're looking at, if those aircraft violate that well-clear definition, what can be done? Do these JOCA algorithms work? Will the airplanes autonomously maintain the separation and stay out of that envelope? The answer is yes, it's working. Very, very early, but it's technology now that certainly can be applied to UAS going forward. Obviously, we got to get the size, weight, and power issues down and so on so that it can be operated across the board. But there are paths to solutions, and you know, they are really, really things that I would hope that many of the entities here within the state would get involved in going forward. Another mole coming up. I hesitated putting this up, but it's something that's going to make my hair really go nuts here over the next couple of months. There's an organization called Light Squared. You probably heard about it. Several years ago, you know, they made a run at coming up with a system to provide essentially internet services everywhere. It's a systems network of satellites and ground stations and so on that would increase or expand, you know, internet and GPS coverage, you know, globally. Interesting idea, but it had a lot of fleas on it. FAA did a fairly robust study of that and ultimately came up with concerns that kind of derailed that process going forward. Well, it's back. There is another run by the company to essentially put up or put together a network of ground stations that will radiate on frequencies very close to that of GPS. And because of that, there is concerns that have been identified by the FAA through a study that they did last year called the Adjacent Band Compatibility Study. That's a mouthful. But they basically looked at this whole concept and decided that it would probably be necessary if, in fact, Light Square does what they want to do. There would be a need to establish what they are calling GPS exclusion zones, primarily in rural areas that would be very close to these transmitter sites. FAA right now is very interested in finding out what the impact of those sites just might be, not only to UAS operations, but also helicopters. So our TCA has been asked to address that. We will begin that process next week, on the 10th. We're bringing together all the principals, and we're going to be looking at scenarios that involve UAS and helicopter operations that may in fact be impacted by the establishment of these GPS exclusion zones. We don't know what the real ramifications of this are yet, but again, it presents yet another technical challenge, something that we may have to face going forward. So anyway, I've probably gone way over, and I apologize for that. I could go on for days, as most of you know. But again, there's more than enough opportunity here. I applaud Grant and the team for putting together this conference. Ask questions, please, get involved. There's a lot you can contribute. This state has a lot to offer. You heard what Jim said. Been working with him and the Space Florida team now for some time. Opportunities are endless. And I would really encourage you all to stay engaged in this, help us as an industry solve these crazy technical problems, help us knock these moles back into the box, and let's get this thing done. So thank you all very much.
Thank you very much, Paul. And a Floridian about Florida's opportunities, and I assert again, you could not find a better speaker. And so thank you very much, Paul.